Hey Bobcats, I hope you're doing well. What I'd like you to do is pause this for a moment and get your page set up. So you need to put your name here, what period you're in, and the date. And today we're going to be determining the probability of an event and its complement. And then you'll be able to identify the probability of an event between the numbers 0 and 1. Now, we did a little bit of this already yesterday, so it's kind of review and then some new stuff as well. So pause it, make sure your page is set up, and then click play, and then we'll carry on. All right, so let's start with some vocabulary. We're starting with vocab. We're going to actually define complementary event. And then I'll show you some examples of it too. So a complementary event is an event, or actually it's an event that, no, actually I'm gonna rephrase that. I'm gonna say, let's do two events that together contain all of the outcomes. In the sample space. Okay, so for an example, we talked a lot about the number cube yesterday, okay? So complementary events in this case might look like this. The probability that you roll an odd number. Well, remember on a number cube, the numbers are 1 through 6. That's the sample space. So the odd numbers are 1, 3, and 5. So that means your probability of getting an odd number is 3/6. And if we simplify that fraction, you get 1/2. Now just a reminder, we can represent this as a decimal, as 0.5 or 50%, but we're gonna leave it as a fraction for this case. Now, the complementary event to this event would be all the other outcomes. So for a number cube, that would be all the even numbers. So 2, 4, and 6. That's 3 outcomes out of 6 possible outcomes. And when we reduce that, we get 1/2, okay? Now, if 2 events are complementary, their probabilities are gonna add up to 1, or if you're looking at the percents, it would be 100%. So we can say these are complements. And then I'm gonna put underneath it here that is sum of 1, okay? So keeping that number cube in mind, I want you to practice one. So first I want you to find the probability of rolling a number that is 5 or higher. And then I want you to find the probability of rolling a 4 or lower. Okay, go ahead and pause it, write the probabilities in there, make sure you simplify your fractions, and because these are complementary events, it should add to 1. All right, let's see how you did. For 5 and higher, so that means 5 and 6. That's 2 possible outcomes out of 6 total. And when we reduce this fraction, we get 1/3. So the probability of rolling a number that's 5 or higher is 1/3. Now let's do the probability of 4 or lower. So that's 4, 5, 6, or sorry, 4, 3, 2, and 1. So that's 4 outcomes out of 6 possible outcomes. And when we reduce this, we get 2/3. Okay? To be doubly sure that these are complementary events, these should add up to 1. And you can see that they do. Okay, so this is a sum of 1, which means they're complementary events. Now, let's take a look at another example so you can see how another way that complementary events can work. I'm going to scoot this up a little bit. Okay, so I'm going to try to freehand a spinner circle here. That has, let's do 6 equal parts. Okay, so let's say that this area is the number 1. This area is the letter X. And then we have 3, 5. This is the letter Z. And this is the letter 2. Now, whenever I do a Z in math, I always put that little line through it, just so you know that's a Z and not a 2. So if you're ever wondering why my Z's look that way, that is the reason. Okay, so let's talk about the number of possible outcomes. So we have the number of outcomes is 6. Okay, and then let's list out the sample space. Remember, a sample space has to have those really awesome squiggly brackets. So it looks like this. Now, the sample space here we have is X, 3, 5, Z, 2, and 1. Okay, so these brackets tell us we're talking about the sample space. So, complementary events. There's a lot of different complementary events that we can pull from this particular spinner. But let's go ahead and first look at the probability of getting a letter. So if you're looking at the probability of getting a letter, the complementary event to that would be getting a number or not a letter. So we'll actually label it this way so you can see what this looks like too. So not a letter. So you have a letter and not a letter. Well, in this case, letters, there's 2 out of 6 possibilities. So the probability is 1/3. Or we can also say 0.33. We're going to round it to the nearest hundredth, or 33%. Okay? And then not a letter is going to be 4 possible outcomes out of 6, because you can see that these 2 are letters, these 4 are not letters. This is 2/3. We're going to round it to 0.67, which would be 67%. Okay. And if you add these up, the percentages, you get 100%, which works the same as getting a sum of 1. When you get a sum of 100%, when you're looking at percents, that is also considered a complementary event. Okay, your turn to practice. So let's try this. The probability of getting an odd number and the probability of not an odd number. Okay, go ahead and find those probabilities. You're going to want to pause your video for a moment so that you have a chance to do that. Okay, so let's take a look. How many odd numbers do you see? 1, 2, and 3. So that's 3 out of 6, which when we reduce that, we get 1/2. And we can change that to a decimal and to a percent. So we get 50%. Then not an odd number. Okay, so this is not an odd number. This is not an odd number. And that is not an odd number. So again, we're going to get 3 out of 6, which will be 1/2, 0.5, and 50%. And notice that these percentages add up to 100. The fractions add up to 1, so we know that those are indeed complementary events. Okay. So yesterday we looked at the scale of likelihood for events. So we're going to do that again real quick, and we're just going to run through some examples. So we had 0 being impossible, and we had 1 being certain. And we had in the middle here, 1/2 is equally as likely. So we decided right here, this whole area from 0 to 1/2 is unlikely. And this whole area from 1/2 to certain is likely. I'm gonna underline these. So we have impossible, unlikely, likely, and certain. And this one we can call just as likely. All right. So let's look at a few examples, and we'll talk through this too, because you need to be able to relate this to real life. Okay. So I'm going to set up a little table here. And we're going to find the fraction, the decimal, and the percent. I don't have a ruler here, so it's kind of roughing it. Okay, so the first example is next baby born is a boy. Okay. Well, I know that this is not a perfect system, and it does show that there is a slight discrepancy between boys and girls, but for the sake of this argument, we're going to assume that it is an even 50-50. That on the scale, it's just as likely that it's a boy as it is likely that it's a girl. So for our fraction here, we're going to do 1/2. Our decimal is going to be 0.5, and our percent will be 50%. So here we go. The likelihood you get a pet dinosaur. Okay. Dinosaurs are extinct, so unless it's a plastic dinosaur, you're probably not getting it. Let's assume that we're talking about a real dinosaur. The likelihood of getting that dinosaur is right here. It's impossible. You will not be getting a live dinosaur. So this would be 0, 0, and 0%. Okay. Let's do one more example. Let's do the likelihood that you will have a quiz next month. So given that you're in school and you have 6 classes, the likelihood that you have a quiz is pretty much certain. So even though it would be, I would consider this one likely, highly likely, we're just gonna roll it up to certain. And let me just tell you, I am certain that you will have a quiz in the next month. So So the probability of that would be 1, your decimal would be 1, and your percentage would be 100%. Okay? All right, eventually I'm gonna have you start doing your summaries, but today we're gonna skip it. Please make sure you file these notes behind your table of contents, and you do have some practice assigned to you. All right, Bobcats, hope you enjoyed the lesson and have a great day.